In this video, I am going to solve the second question from chapter 15, Oscillation. An oscillating block spring system has a mechanical energy of 2 joules and amplitude 10 centimeter and maximum speed of 0.8 meter per second. So you have an oscillator. An oscillator consists of a spring block system. So by that it will have the mechanical energy, and here I'm going to write the mechanical energy as caps E, which is 2 joules, and when the spring oscillates it has an amplitude value xm which is equal to 10 centimeter. So I have to write this centimeter in terms of meter. So 10 multiplied by 10 power minus 2 meter, and also it has the maximum speed as 0.8 meter per second. By using these three values, we are going to find the answer for three questions. What are they? In the first part, we are going to find a spring constant. So for answering the first question, we are going to find the spring constant K. What is this K? This K is called as spring constant, right? So we are going to find the value of the spring constant. For that, I have to use the mechanical energy formula equation. The mechanical energy E, which is equal to a combination of potential energy plus kinetic energy. And when the oscillator oscillates to an amplitude of 10 centimeter, by the time it will not have the kinetic energy, only it will have the elastic potential energy. By that, this kinetic energy will be zero. That means its speed is zero initially. So by that, we will get the formula only for the elastic potential energy as half K xm square. This is the rule, right? Now I'm going to rearrange this equation in terms of spring constant. So if you rearrange this equation in terms of K, therefore K, which is equal to 2 multiplied by mechanical energy divided by the amplitude square. Now I'm going to substitute the values here. We have the mechanical energy E takes the value of 2 joules, and then the amplitude is 10 centimeter. So 10 multiplied by 10 power minus 2 the whole square, right? So if you calculate, you will get the answer for the spring constant, right? So I'm going to calculate this. So 2 multiplied by 2 is 4. So 4 divided by 10 multiplied by 10 power minus 2 the whole square is 400. What's the answer? 400. What is the unit for the spring constant? Newton over meter. This is the answer for the first part. Clear? And now we have to answer the second question. Find the mass of the block, because the mass is not mentioned in this question. So we are going to find the mass of the block. So if you want to find the mass of the block, again we have to deal with the energy equation. So what is the energy equation? The mechanical energy E, which is equal to potential energy plus kinetic energy, right? So when the block started from its equilibrium position, it will have the maximum speed. By the time it is purely kinetic energy. So by the time your potential energy will not be here, therefore my energy, mechanical energy E, which is equal to half m Vm square, because it will have the maximum speed by the time. So I am going to rearrange this equation in terms of mass. So therefore the mass m, which is equal to 2 multiplied by E divided by the maximum speed square. Now I am going to substitute the value. 2 multiplied by our mechanical energy value is 2 divided by, I think the speed value is 0.8 meter per second, right? Yes, it's 0.8 meter per second. So I have to square this value, 0.8 square. So now I'm going to calculate. By that we will get the answer for the mass. So let's calculate. So 4 divided by 0.8 square, I got 6.25 kilograms. So what is the value of the mass? Mass value here is 6.25 kilogram. It is not 625, it is 6.25, right? So this is the answer for the second question. Okay. Now we have to answer the last question. What is given in the last question? Find the frequency of oscillation. So in the theory, we already had the relation for finding the frequency. So we already know the frequency will be given by the term which is 1 over 2 pi square root of the spring constant over mass. So this is the equation we studied in the theory. Am I right? So now I'm going to substitute all the values which we already found in the previous parts, because in the first question we found the value of the spring constant, in the second part we found the mass. Once you substitute the value, you will easily find the answer for the frequency of the oscillation. So therefore F, which is equal to 1 over 2 pi square root of, what is the value of the spring constant? I think it's 400, right? Yes, 400 divided by our mass value is 6.25, right? So now I'm going to calculate the value, the right hand side. So 1 over 2 pi multiplied by 400 over 6.25, I got 1.273. What's the frequency? 1.273 hertz, or 1 over second. So this is the answer for the third part. So this is the answer for the third question. Correct? Clear? So we have three subdivision. So we found the answer for the three questions. In the first part, we found the value for the spring constant. In the second part, we found the value for the mass. And third one, we found the value for the frequency. Clear? That's it.